Perkins reaction is an organic reaction developed by chemist by name William Henry Perkins. Perkins reaction is used in the preparation of alpha beta unsaturated aromatic acid. Alpha beta is the position next to the functional group. Unsaturated mean it has double bond. Aromatic means it has C6H5 group or aromatic compound related to benzene, and acid group here stands for COOH. So Perkins reaction is the reaction given by the same scientist which is used in the preparation of cinnamic acid, which is also called as alpha beta unsaturated aromatic acid. So it gives a compound that is cinnamic acid. This reaction occurs between aromatic aldehyde example is benzaldehyde reacts with acetic anhydride. Acetic anhydride, all of you know the structure of benzaldehyde. Benzaldehyde is either this structure with C double bond OH. This structure can also be written as C6H5 C double bond OH is benzaldehyde. And acetic anhydride is derived from acetic acid. That is, if I try to combine two acetic acid, that is CH3 C double bond O OH plus HO C double bond O CH3. When two acetaldehyde combine, followed by elimination of water, OH from one side, H from one side, we are going to write this part as it is, that is CH3 C double bond O. This part is eliminated in the form of H2O, and this remaining part is O C double bond O CH3. This compound is called as acetic anhydride. So benzaldehyde is going to combine with acetic anhydride. Acetic anhydride is also written as, because we have CH3 C double bond O and CH3 C double bond O written twice, it is also represented as, or it can be represented as CH3 C double bond O taken twice. Leftover part is O, so O. In some textbook and even in my notes also it is represented in the same way, where I can directly write CH3CO twice along with O. That means it is anhydride. Anhydride means by the removal of water molecule. So this is the water molecule which is eliminated when two acetic acid combines. It results in the formation of acetic anhydride, which followed by removal of water molecule. So this is what we get the acetic anhydride from. So acetic anhydride is going to combine with your benzaldehyde in the presence of sodium acetate. in the presence of sodium acetate. Sodium acetate is derived from, we have CH3 C double bond O OH is acetic acid. This combines with NaCl. H and Cl will be removed as HCl. Leftover part is CH3 C double bond O O minus Na plus. This is a salt form. It is called as sodium acetate. So it's called as sodium acetate. So what we are going to write in the reaction of Perkins is Perkins reaction help us in the preparation of cinnamic acid. It is also called as alpha beta unsaturated aromatic acid. Alpha beta is the position next to the functional group. Unsaturation is double bond. Aromatic acid is something which is relatable to benzene, that is CCH5, the phenyl group, and acid group is COH. We are going to actually derive cinnamic acid using an aromatic aldehyde. Example is benzaldehyde, and how it is represented we have already seen it, followed by the reaction with acetic anhydride, which is made in this particular form, and sodium acetate is actually prepared when you combine acetic acid with a salt. That is why it is called as alkali salt of the acid in our notes. So in the example we have written benzaldehyde reacts with acetic anhydride in the presence of sodium acetate at 180 degrees Celsius to form cinnamic acid. We are going to represent that particular statement in the form of a reaction. So this is your benzaldehyde, C double bond OH and CH3 C double bond O O C double bond OCH3. I'm writing in this form. In the presence of sodium acetate, CH3 C double bond O O minus Na plus. In the presence of 180 degrees Celsius, it gives this is alpha, this is beta, C double bond O OH. This is a functional group COH. This is actually COH group, that is acid group. Next to that is alpha carbon and this is beta carbon. And alpha beta is the position, unsaturation is the double bond we have written or represented here, and acid group is COH group. So we are going to form this acid, that is cinnamic acid or alpha comma beta unsaturated aromatic acid. So this is this compound we are going to prepare when we are going for a condensation reaction using benzaldehyde, acetic anhydride and sodium acetate. We are going to get this product. The mechanism for this reaction is involving following step. Step 1 is the acetate ion, that is CH3 COO minus, is going to react with acetic anhydride. I'm going to write acetic anhydride CH3 as CH2, and the another hydrogen is actually together called as CH3 bond C double bond O O C double bond O CH3. That is the acetic anhydride. This particular hydrogen is going to be removed as proton, and this particular bond is going to shift to this particular carbon. In this case, we are going to get a negative charge on this particular carbon. So now we are going to represent this in a way that is CH2 with a negative charge. That means it has 2 electrons, followed by the entirely same thing, that is C double bond O, O, C double bond O, CH3 plus this group now will be represented as CH3COH, CH3, C double bond C double bond O, OH, or directly will be represented as CH3 COOH, that is acetic acid. So the first step is we are going to generate a negative charge on this particular carbon, that is called as anion of acetic anhydride. So the negative charge represents the anion in this particular group was actually acetic anhydride. The second step is reaction between the benzaldehyde and the anion of acetic anhydride. So we are going to write here first benzaldehyde is, I think in our text I have represented as C6H5. We can write benzene structure, phenyl structure or C6H5. So C double bond O, I'm writing H here, plus anion is CH2 with a negative charge, that is having 2 electrons, and as it is compound which we have already written here, that's C double bond O, O, C double bond O, CH3. What happens here is, due to the difference in electronegativity, oxygen will have partially negative, carbon will have partially positive. The negative charge that is having 2 electrons will actually be attracted towards carbon having positive charge. That leads to formation of a bond with the carbon, that is condensation reaction, which gives us this particular product, that is benzene ring. The oxygen having negative charge, hydrogen as it is what we wrote here. This part is going to come, that is CH2 C double bond O, O, C double bond O, CH3. So this is the reaction intermediate what we are going to get in our second step. In the first step, acetate ion, that was this compound, reacted with acetic anhydride, that leads to the formation of anion of acetic anhydride. The acetic anhydride is going to combine with benzaldehyde, and that leads to a condensed intermediate. This condensed intermediate is going to undergo this particular third step, where the intermediate what we got here I'm going to write the CH2 as CH and H. C double bond O, O, C double bond O, CH3 as it is. we're going to get protonation of addition of proton here in this step, where proton is going to attack oxygen having to the oxygen having negative charge. The proton what we are going to get is due to the acetic acid formed in the first step. What we got here, acetic acid is going to release a proton from itself that leads to formation of the structure. There is now OH and H, CH and H as it is, C double bond O, O, C double bond O, CH3. Now after we get this intermediate, we are going to go for our fourth step. We are still away from our product. After for protonation or internal proton transport, we are going to go for elimination of water molecule so that we get unsaturation or double bond. That is C. For better representation, we'll write C OH. Here H was already there. C H H and C double bond O, O C double bond O, CH3. This step is where we are going to remove water molecule so that we get unsaturation or double bond. This bond shifts here so that oxygen will get negative charge, that is OH minus, and this hydrogen will be removed as H plus, that is proton. This OH minus and H plus will combine to form water, and which will be removed, and this particular bond will shift here so that it results in the formation of a double bond. So we are going to write here benzene or phenyl ring, then this I can write here CH double bond, and now only CH is remaining, so CH, so C double bond O, O C double bond O, CH3. So we are just away one step or one reaction away or one step away from a product, that is alpha beta unsaturated aromatic acid. Fifth step is hydrolysis of the given product. So how are we going to go for hydrolysis is breaking in the presence of water. So I'm going to write this reaction once again. CH double bond CH, C double bond O, O C double bond O, CH3, undergo hydrolysis in the presence of water, that is H OH. We are going to get a product when we break our compound here, that is breaking or lysis in the presence of water, where H will go to this part where the bond will shift here, so oxygen will have negative charge, so this will go in the form of H plus, and OH will be in the form of OH minus, will go to this part. This results in the formation of benzene ring as it is. We had CH double bond CH and C double bond O. Now because this is broken here and OH part comes to this particular position, we are going to get OH here. So this is alpha beta unsaturated aromatic acid plus CH3 C double bond O, along with this H is nothing but acetic acid, that is CH3 C double bond OH. So this is very simple named reaction, that is Perkin reaction of carbonyl group, where we are going to get alpha beta unsaturated aromatic acid, that is cinnamic acid, following this few steps. It is a very simple reaction, very easy to remember if you understand what and what are your reactants in this particular reaction. Perkins reaction is going to give you alpha beta unsaturated acid, where we are going to use benzaldehyde in the presence of acetic anhydride. We are going to use sodium acetate, which we are going to get with the help of acid and a base, where we are using acid as acetic acid and base as NaCl. And this reaction will give us an unsaturation which is at alpha beta positions, and the acidic group here is COH group. The first step is where we are going to use the acetate ion, that is CH3COO minus, which is going to react with acetic anhydride to form an anion of acetic anhydride. The anion of acetic anhydride is going to combine with the benzaldehyde, which results in the formation of an intermediate, and this particular intermediate is going to undergo protonation reaction followed by hydrolysis to give us a product, that is cinnamic acid. Thank you.